Welcome everyone, my name is Faulkner. I'm the online event coordinator for staff development for educators. And I would like to thank you for joining us today for Q&A, exploring solutions to your math instructional challenges, grades 1 through 3 with Char Forsten. Before we start, there are a few things you should know. To allow for Char to be heard clearly, attendee microphones are muted. Most audio and video problems you might experience during the presentation can be solved by closing any other programs and applications you might have open on your computer. The session is being recorded, and assuming no technical difficulties, you'll receive a link to the archive in approximately 48 hours. And at the end of today's presentation, you will see a short survey, and by completing that, you do help us provide you with future complimentary webinars. Now, a quick bit about SDE. At SDE, we believe educators have the most important job in the world, and that's why it's our mission to empower pre-K through 12 educators across the country with sustained professional development solutions that are not only research-based and rigorous, but also practical, innovative, and fun. Our goal is to help you create environments that prepare your students for the evolving demands of the 21st century. Together, we can create extraordinary classrooms. We're pleased to have Char Forsten joining us for today's webinar. A former teacher and teaching principal for 18 years, Char is a popular presenter who now works frequently as a consultant in schools and classrooms across the country. She's an expert in elementary mathematics, differentiated instruction, writing, and is best known for delivering presentations filled with practical, easy-to-implement, classroom-proven strategies and activities. Char has presented on Singapore Math at national and international conferences and has traveled to Singapore numerous times to experience firsthand the groundbreaking approach in action. She is the author of many books, including Math Talk and Step-by-Step Model Drawing, Solving Word Problems the Singapore Way. Welcome, Char. At this point, I'm going to turn it on over to you.
Thank you, Faulkner. And let me add my welcome to all of you, and thank you for giving up time during your busy day and week to attend this webinar. As Faulkner, as you saw, and as you already know, this was a Q&A where you submitted questions that you would like some help with your instructional challenges. And what's very interesting is that we got numerous questions. So I need to tell you ahead of time before I begin that there's no mathematical way we could possibly, or I could possibly address all of the questions in this half-hour webinar. So my deep apologies ahead of time. However, the way we will handle this is I will do my webinar, and the questions that you have submitted that are not addressed here, I am going to type up my suggestions or solutions or resources to you, and that will be emailed to you within the next few weeks. So thank you ahead of time for your understanding. So what I did when I looked at all of the questions, I put them together according to themes, you know, being the teacher that I am. And one theme, if you will, that had a lot of questions was regarding number bonds and then math facts, a number of different kinds of questions about these. So I am going to start by addressing those questions relating to number bonds and math facts. And one question was, what about memorizing math facts? What about time tests? What about fluency? So let me share a few of my thoughts. I've always believed this, that math facts are to math what sight words are to reading. And so I do not believe in simply memorizing. In fact, that's what I did as a student. I memorized everything, and that's what we were assessed on. Our tests were on our memorization, but we weren't making meaning. And so when we compare it, when we make the analogy to sight words, early childhood teachers know that in order for a child to comprehend, they need to front load with those sight words. They have to understand them and they have to recognize them. So they build the understanding and they do multiple repetitions so that when they encounter them, it does not interfere with understanding, comprehension. And for me, it's the same with math facts. So at first, they must understand them because there are so many relationships within the math facts, but then they're basically using these to work at higher levels. So I believe this, that simply memorizing math facts is like memorizing nonsense words. You can repeat them, but they have no meaning. And so I know where a number of you brought this up. I'm going to give you an example. Let's just say you're teaching multiplication facts, and we have 5 times 6 is equal to 30. A child who simply memorizes that, the cue is 5 times 6, and they can tell you 30, but they can't tell you anything more. What I mean by understanding is a child who's been taught with concrete objects and visuals where they see 5 groups of 6 or 6 groups of 5, or they see an array, so that they start to begin at an informal level understanding the commutative property. They can see then, they can easily see the relationship between multiplication and division, that 30 divided by 6 is 5, 30 divided by 5 is 6. And all of that is concrete and visual, and later this 5 times 6 is 30 is grounded in relational understanding. Then you see when they get to fractions, they can see 1/6 of 30 is 5, and vice versa, 1/5 of 30 is 6. So in Singapore math, an important concept is moving from the informal to the formal, and also Jerome Bruner's concept of mastery, teaching for mastery. And the idea is to get away from reteaching, to having solid foundational work, and constantly going to the next level of complexity. So those are some few things. I was asked about time tests in Singapore. I know a number of schools in the U.S. use something called sprints. In Singapore, they don't do many time tests, and I'm going to let you know what they do here. Okay. So there were a few questions on what is the progression for number bonds, and how do you help a student move from a number bond into a math equation. So let's go there, okay? So for example, if you've been with me at all, you've heard me do these math talks, and I love doing them. And again, we're starting with the informal, where we can see how numbers work together. So this is called a math story. I want you to look at those spiders on the tree. Sometimes when I work with children, they think they're crabs. I go with whatever they think they are, but we'll call them spiders today. So I might ask, are all of the spiders on the tree or part of them on the tree? And use your right hand and show me what part. So they might show me 3. They might also have manipulatives. They might have a number bracelet. Are all of them on the ground or part of them on the ground? With the other hand, they show me 2. And what do we know? 2 and 3 make 5. So what we're doing initially with just this one example is the idea of how numbers go together, and we make up number stories. So you can see the frogs have potential, and a lot of the picture books you use have great potential for doing these math talks and introducing informally number stories. So then they move and they actually see, early on in first grade, they learn the structure of this number bond. And this structure will follow them throughout the grades. And again, just the idea of moving along in complexity, that number bond symbol will be used in increasing complexity. So now I have this photograph of goats. And what I'm trying to do is move my first graders, or whatever students, whatever is appropriate. Some of you might be working with upper grade students who really need this. So I'm going to move my students from number stories into this idea of a number bond. And number bonds are for addition and subtraction, and to develop part-whole thinking, which is going to be critical for fractions later on too. Okay? So an example again. What's different? I've moved on in complexity. Now I want the children to give me a number bond story that shows that part of them, 3 of them have one thing in common, attributes, and 2 of them have another thing in common. So where I can't hear you talk, if you look at this, someone might say, well, part of the goats, or 2 of them, have blue collars, and the other part, 3 of them, don't have any collars, and 3 and 2 make 5. We could also tell the story by starting without the goats that have collars and add the 2 that do, and we can tell that story 2 and 3 and 3 and 2. Either way, it makes 5. So this big idea now is that children are going to look for attributes that make that number bond true, okay? And again, I mentioned the number bracelets. Catherine Coons, if you're familiar with her work, she shares how to make these. They're great. And again, it's a Singapore Math believes in multiple modes of representation. So the more ways kids are working with these concepts, the more they're consolidating their learning into long-term memory. Okay, so then how do we get the kids to stretch out a number bond into a math sentence? So the picture you see here is of a classroom I visited in Singapore where this teacher, every time they had a target number, the number they were studying, they started with the number bond, and then using pictures or manipulatives, they learned all the different ways. 4 and 0 make 4, 3 and 1 make 4. And all of that was based on a contextual experience as well as informal language that the children use. And that's done in kindergarten and also at the beginning of first grade. So in first grade, they would have had the number bonds. How do they get them into the number sentences? Well, this, if you look at this particular paper, it's from a first grader in Singapore in February this year. They start school on February 2nd. So it's about a month into the school year. So for those of you who were concerned that kids are not retaining their number bonds, these are very, very foundational. And what looks easy to some people, you've got to remind them it's not easy, it's foundational. Okay, so now what they've done is they've stretched them out, and you can see the number bonds are in sentences, still using the informal language. But down below, take a look, and this might give you some ideas for your own classroom. So this child, pick one number and number bond and tell a story about it. So 1 and 4 make 5. 4 exclamation points and a question mark. I thought that was rather clever. So they still view these, they're number bonds. It's just a different configuration. So then this is the big question. How do I move them into formal equations then, you know, where it's plus is equal to? So I want to give you a teaching idea for this. So what I do, we take what they already know, here's the number bond, and I get Post-it notes. And I use one color for the parts and another color for the whole amount. So here I've covered up the number bonds with the blue for the parts, and I put the 3 and the 2, and the whole amount is yellow. And then I'm going to need to draw this. The next thing I'm going to do with the students is we're going to remove that 3 and bring that Post-it over here. Okay, and then we're going to take this Post-it and we're going to put it here. So 3 and 2 make 5. This is how we help them with what you saw on that previous page. But I want you to think about this. Can I also then pick up this Post-it and switch it with this one? So informally, I'm reinforcing that commutative property. Can I also do this, where I ask them, is this true? And so there's a lot simply by moving these Post-its around. You can say, is this true or not true? And due to the time constraints, I'm not doing subtraction here, but I think you'll get the idea of how to do that. So then, here is how, what I noticed. They use intentional language combining with what's already known to what's new. So 3, if I were teaching students, I'd say 3 and or plus 2 make or is equal to 5. And I would do several of those with them. And I'd say, what did you notice, kids? What did you see that's new? I said plus here, and what did we say here is equal to? So it's scaffolding, and what I'm going to do then is remove the and make, or some of you use is the same as, which is great. And pretty soon they're using 3 plus 2 is equal to 5. 5 minus 2 is equal to 3. I hope that makes sense. One question was, and I'm not sure if I interpreted it correctly, but can some of the graphics from Singapore math be used in other areas of the curriculum? And I was in a class, a first grade class, where they were learning English. Look at the number bond part whole concept for contractions. So they've got, here's the contraction, here are the parts. Can we also do that with compound words? Again, making it easy for the kids, part, whole. And those of you who teach upper level science, can you imagine compounds where you break them down into the elements, part, or part, whole? It's just a structure that allows kids to focus on the concept. Okay, so the number bonds are the addition and subtraction facts, and later on a way of breaking down large numbers too. But let's take a look, because there were questions about multiplication and division facts. So once again, thing about multiplication and division, these are pretty critical for success in fractions and algebra later on. And in Singapore, when they are trained, they have to know the whole curriculum. So they have to know where their kids are going, even if they teach first grade. They have to know the sixth grade math. They know where they're going. Because the goal is to keep the kids building on a foundation from each grade level. So let's start early. In even first grade, they do some very informal work with multiplication and division. But for those of you new to Singapore math and those of you considering adoption, here's what's very different. Multiplication and division are formally taught over a 2-year period. The facts, excuse me, not multi-digit. The multiplication division facts are taught in 2nd and 3rd grade. Because they are so important and they want time to really get them in deeply and consolidate them into long-term learning. So I like, when I'm in the States here, I like to use photographs, real objects, of course, but photographs. So here I can see the relationship between multiplication and division. I see an array, 2 groups of 4. I can turn that array, 4 groups of 2. So for some of your students, I want to give you the idea of using photographs to have them generate multiplication and division stories, much like we did with the number bonds. So I could say if each gingerbread man has 3 buttons and there are 8 gingerbread men, how many buttons in all? Or vice versa, if there are 24 buttons and each gingerbread man has 3 buttons, how many gingerbread men are there? So there's a lot to be done with photographs. But here's a 2nd grader, and this approach is very common in 2nd grade, and then they start to do less of it in 3rd. So here's a 2nd grader. They're starting their 3s. You'll notice the concrete. They've got 5 groups of 3. Now look at the multiple modes of representation. Repeated addition. I've got 3 5 times. I've got 5 groups of 3. And they still aren't finished because this next one, which is an entirely different class to show you the consistency, again, linking cubes, I've got repeated addition, I've got 2 5 times, I've got 5 groups of 2, and then here's the one I want to point out, 5 2s. They do this when they're learning all of their facts in 2nd grade. Quantity, value, very important. How many of what? Adjective, noun. So later when they get into place value, you know, I have 3 10s, quantity, value. When I get into fractions, I have 3 fifths. Quantity, what? 3. Value, what? Fifths. So there is a great deal of this emphasis throughout the curriculum to help the kids differentiate between the two. Then, we're already 20 minutes into this. Another content question in here that was a little bit different, but I wanted to include because I need to do some graphics with it. A few people asked about long division. So not simply division facts. So again, with this idea of going informal to formal, the idea of spiraling for mastery, this could be what Dr. Yip Van Haar calls an anchor task. Now, if you haven't seen these before, these are place value discs. The red are the 10s and the 1s are whites. You can also use base 10 blocks. So in Singapore, depending on your program, they introduce place value discs at different times. What Banhar has told me is make sure the children have a strong working knowledge of place value in the thousands, and very strong, because now these discs are the same size. But they're easy now to understand operations. Okay, so I would ask the kids, here's what I'd like you to do. What do we have? We have 10, 20, 30, 40, 41, 42, 43, 44. Would you take 44 and divide that into 2 equal groups? And I'm going to watch as the students literally divide the 10s. And I'm not going to put circles around them to keep time. And then they're going to do the 1s. They might do it differently than what I'm doing. But the whole idea is they've created equal groups. So I'm going to ask them, did you take 44 and divide them into 2 equal groups? Yes. So how many are in each group? 22, 22. Can you see I can instantly make the connection to multiplication? So 2 equal groups of 22 gives us 44. So paper plates, base 10 blocks, or place value discs. So from there, let's spiral. And now I'm going to give them a little more complicated task. They're still, this is before actual long division, the algorithm. But I'm going to ask them now, would you do the same thing? What do we have? We have 34, and I want you to divide it into 2 groups. And they're working, by the way, someone had asked about individualized instruction. In Singapore, they believe very strongly in collaborative work. Independent work is done just that, individually. But when kids are learning, you'll almost always, when you walk into a classroom, see small group or partner work. So can you imagine that the kids are going to do something like this? So they're going to take a 10 and a 10. And then this one is the dilemma. And some of them will ask you, can I break it in half? And you're going to tell them, no. And so what we're going to do, they would have learned to trade before this. So we're going to trade it for 10 ones. So now, do we still have 34? Well, we have 2 10s with a value of 20, and we have 14 ones. Do we still have 34? Do you see how that number bond is being used now to show how we decomposed it? So then they would literally divide up the ones, and again, I think you get the idea here. So when they divide 34 into 2 equal groups, they have 17 in each group. And again, we can go backwards and multiply. So this is preparing them then for long division. So now you'll notice what we're going to do is we're going to rename or regroup. Different programs use different words, regrouping and renaming. And there will be a remainder here. But also, this is what some of you asked about that long division algorithm. Now, I don't know about you, but sometimes kids use mnemonics: divide, multiply, subtract, check, bring down. Dad, mother, sister, cousin, brother, does McDonald's sell cheeseburgers? And that's what guides them through long division. Not understanding, but a mnemonic. And so let's go for some understanding. So what I'm going to do is I'm going to say to the children, we're going to learn something new. And here's the place value mat. Certainly the first time they see a place value mat is not for division. But for division, what we're going to do is we're going to show what we're dividing in the dividend down below. So we have 3 10s with a value of 30, 5 1s with a value of 5. So we have 35, and I would like you to divide those into 2 equal groups. So one reason I like kids to laminate their place value mats is so they can write on them. So now what a student would do, and I'm going to have to draw it where they would move these, they're going to divide their 10s, aren't they? So there's 1. Now they've already experienced that dilemma of regrouping or trading, so now they know they're going to have to take this 10 and trade it for 10 ones. So 1, 2, 3, 4, 5. So once again, let me show you, we have that 35 and 20 and what? 15. Okay, so now they would do this. 15, they're going to do 1, 2, 3, 4, 5, 2, 3, 4, 5, and then 1, 2, 1, 2. And what there is there's there's one remaining then, isn't there? So if we put 7 in each, there's one remaining. So we've got 14 and one remaining that doesn't fit. So how does that get transferred to the algorithm? We're going to take that concrete model and we're going to guide the kids through it. So listen to this. And again, you're going to be able to revisit this. You're going to be given the link within 48 hours. So we divided 35 into 2 equal groups. And we started with the 10s. And when we divided those 10s into 2 equal groups, how many 10s in one or each group? 1, right? But how many 10s did we divide on that first step? We did 2 10s. We divided a value of 20, didn't we? I like to have the kids show that 20 because a lot of them don't understand that 0, they drop the placeholder, if you will. So of this, we've divided up 20. And what did we have left? Now, the kids, I'm going to ask them, when we divided the 2 10s, we had 15 left, didn't we? Well, look in the algorithm. How many do we have left? Doesn't that imply subtraction? We can look at the concrete, but we see 15. So then we had those 15 ones. We traded, got 15 ones, and when we did our division, we found that we could put 7 ones in one or each group. But we did 2 groups of 7, which gave us a total of 14. Was there any left? Yes, there was 1. Oh, look how we can get that. 17, remainder 1. Now, I did 1 with you. Can you imagine where we would do a number of these? And pretty soon, their use of that long division algorithm is based on understanding and not simply some steps, okay? It doesn't mean you can't help them with the steps, but that's the key. Okay, so I'm going to give, believe it or not, it's almost 4:30. I'm going to turn this back to Faulkner for a minute, and then I'll come back to you as we finish off. Okay, Faulkner?
Thanks, Char. We're going to just do a little bit of housekeeping and give it back to Char so she can try to get in a couple more questions here. Hope everybody's enjoying the presentation so far. We would like to thank you for attending today's webinar, and for that, we actually are giving a 10% discount off SDE PD resources, events, and on-site training if you use the promo code W042716 before May 27th. So basically, you've got a month to use that code. You might be interested in saving 10% and joining Char. She will actually be at our national conference on Singapore math strategies in Las Vegas this July. And if you haven't been to the national conferences, it's really an incredible time with about 6,500, at least over 6,000 educators in one place for a week. It's pretty cool. And do keep in mind that Char and other SD presenters are available to bring their knowledge to your school or district for customized training as well. For more information about PD events, training, or resources, give us a call at 877-388-2054 or visit us at sde.com. And just a reminder that we will be posting the full Q&A as soon as Char is able to get the full list put together, but we will also be sending out the archive of this live webinar in about 2 days after the live event. So let's get back. Let's see, Char, if we can sneak another one in there.
I may try, okay? Oh, I'm sorry. Excuse me, Faulkner. Okay. Some of you had asked questions related to implementing Singapore math. There were a number of questions, as a matter of fact. And you asked about PD. Well, I think any trainer will tell you professional development is key to success, and if you talk with any schools that have adopted it. So here are some quick things for you. Begin with a focus on the underpinnings of Singapore math, because Singapore math is a philosophy of how children best learn mathematics. Too many people get the books and try to make sense of the books. So PD is helpful to understand the underpinnings. Also the pedagogy. What does concrete pictorial abstract look like in a very practical sense? What are examples for each grade level? Let me understand. So now I understand why, and I understand how they present it. You have to decide, will you do a full adoption or will you roll it in? Rolling it in allows the teachers and students to build the prior knowledge and each year add a new grade level. Some districts are not able to do that and they do a full adoption. So PD is needed to help kind of adjust what are the non-negotiables and what are the negotiables, especially in grades 2 and above. In other words, some front loading needs to happen because there's an assumption with each grade level, just as with any math program, that the students have had it the year or years before. So then that's when you need PD to examine how those materials are and how they work together. But now you've been front-loaded with knowledge and those books and materials make far more sense. And one person asked, I teach 3rd grade, is it okay to start with just that grade level? It happens all the time, but I'm going to come back to that front loading. You've got to look, I mentioned earlier, 2nd grade has a lot of multiplication and division in the curriculum. So you're going to need to adjust your, and front load the kids, especially with that, before you begin your 3rd grade curriculum, which means you might have to look at teaching maybe measurement during science, maybe some geometry during your warm-up or circle time or center time. But that is something that I'm happy to address further. And as Faulkner said, there are 21 presenters, all experts in Singapore math this summer. So then PD needs to happen because what strategies need further training, coaching, or modeling? What about new teachers coming on board? So these are some thoughts on that. And again, Dr. Yup Ban Har will be in the sleepy town of Las Vegas with me and many others July 18th through the 22nd. And if possible, it would be great to see you there. And any one of us are happy to arrange some one-on-one time with you if you go and figure out how to help you with your math questions. Again, there are numerous questions. I'm going to be typing up my responses and I'll get them to Faulkner and he will get them to you. Thank you so much for your understanding and giving up of time on this Wednesday afternoon.
Thank you, Char. And I just wanted to interject also about the Singapore Math Conference. And don't be fooled or don't presume. Although it's a Singapore Math Conference in name, it's really best practices, good math strategies across curriculums and across textbooks as well. And so certainly it's not something you need to be a Singapore Math school to be going and learning more information from like Char said. It's just the
That's true.
There,
it's good practices. Thank you. Best practices.
And one thing that I should have mentioned also that for many people it might make a difference, that with any of our public events, for a paid teacher registration, an administrator can go for free. So certainly we want to have as many administrators come and learn what teachers are learning so that they can actually help implement things, make better plans, and really just be supportive of each other when they get back to the school. And certainly sometimes if you tell an administrator, hey, you can come to Las Vegas for free, that might help you out in getting yourself there as well. But again, that code to use to save 10% off if you were interested in that conference or Crystal Springs books, any of our PD resources, was W042716. So if you can remember today's date and throw a W in front of it, you'll be all set. I want to thank Char for joining us today, and I hope everybody enjoyed today's presentation and that you all have a great rest of the day. Thanks for joining us, folks.
And lots more responses will be coming your way.
Thanks, Char. Bye-bye, everybody.
Thanks.